Imagine this. It's 6:07 a.m. on a Monday morning. The first sip of coffee hasn't even hit you yet. You grab your phone, scrolling through the usual overnight notifications, and then you see it, an email from your API provider. The subject line is just two words: your invoice. You tap it open, expecting to see the usual 75, maybe $100. Your app is new, it's getting some traction, but it's still small. But the number you see isn't $100. It's not even 1,000. The number staring back at you from the cold glow of your screen is $21,452. Your heart stops. That's not a typo, that's a bill. A bill that could single handedly destroy your entire project, your savings, your dream. This isn't a fictional horror story. This is the ticking time bomb sitting inside almost every AI application built today. And on this episode of AI Hustle Empire, I'm going to show you exactly how to defuse it. Welcome to AI Hustle Empire, the show for builders, founders, and indie hackers who are turning artificial intelligence into real revenue. I'm your host, and my mission is simple: to give you the tactical playbooks you need to build, launch, and monetize your AI products. No fluff, no theory, just what works. Today, we're talking about the silent killer of AI startups, API cost catastrophe. We're going deep on how a single user or even a single line of buggy code can bankrupt your app. But more importantly, I'm going to give you a bulletproof three-layer defense system, a system to make sure that nightmare scenario never ever happens to you. So if you're running an app that calls out to OpenAI, Anthropic, Cohere, or any other usage-based API, stop what you're doing. You need to hear this. The next 30 minutes could literally save you thousands, if not tens of thousands of dollars. Let's go back to that $21,000 bill. How does something like that even happen? It feels impossible, but it's shockingly easy, and it usually comes from one of three places. I call them the three silent killers of your API budget. The first one is the one everyone thinks of, the saboteur. This is the malicious actor, the person who finds an endpoint in your application that triggers an expensive AI call and then writes a simple script to hit it 10,000 times a minute. Their goal is chaos. They want to hurt you, test your security, or just watch the world burn. They're looking for unprotected endpoints, ways to make your app do a lot of work on their behalf. They might not even be targeting you specifically. They could just be scanning the internet for vulnerable applications. And if you haven't prepared, you're not just vulnerable, you're a target. But here's the thing: the saboteur is actually the least common threat. It's the one we worry about, but the other two are far more likely to take you down. The second silent killer is what I call the superfan. This isn't a bad person. In fact, this is your best user. They love your product. They're using it for everything. They've integrated it into their workflow. They're running huge inputs through it, generating massive reports, analyzing entire books. They are a power user, and they have absolutely no idea that every click, every query, every generation is costing you real money. They see a flat monthly subscription of $20 and they assume they can use it as much as they want. They don't understand that their 100th query of the day might have just pushed your API bill past your entire profit margin for the month. The superfan can bankrupt you with enthusiasm, and you can't get mad at them. It's not their fault, it's yours for not building the right guardrails. That leads us to the third and most insidious silent killer, the ghost in the machine. This isn't an external threat at all. This threat is already inside your house. It's a bug in your own code, a simple, innocent-looking recursive loop, an error handling function that accidentally retries a failed API call forever, a background job that gets stuck and just keeps hammering your API provider second after second. It's silent. It doesn't show up as a crash report. Your app might even look like it's working fine from the outside, but in the background, the meter is running faster than a taxi in a chase scene, and it will keep running all weekend while you're relaxing, completely unaware that your app is burning through cash at a rate of hundreds of dollars per hour. This, to me, is the most terrifying scenario because you are the source of your own destruction. the saboteur, the superfan, and the ghost in the machine. Three distinct threats, all leading to the same catastrophic outcome. Let me make this real for you. Let me tell you about Jason. Jason is a developer I know in 2022. He built a text summarization app. Clean interface, useful tool. He posted it on Product Hunt. Within 12 hours, he had 5,000 signups. He was ecstatic. This was it. His side project was finally taking off. The next morning, he woke up to an email from OpenAI, $14,300. He had $2,300 in his bank account. His app had no rate limits, no usage caps, nothing, just a direct call to the API for every single request. The superfan had discovered his app and they loved it. They ran their entire company's documentation through it, thousands of pages, thousands of requests, all in one night. Jason shut down the app that same day. He couldn't afford the bill. He went back to his day job. His AI dream died in 12 hours. Not because his product was bad, but because he didn't build the right defenses, he didn't have the gatekeeper. That's why we're here today. So the question is, what do we do about it? How do you build a fortress around your API keys? In a few moments, I'm going to lay out the complete three-layer defense system, the system Jason wishes he had known about. But first, let's understand the core principle. You cannot trust the user, and you cannot fully trust your own code. You must build a system that assumes failure and protects you by default. Your architecture has to be defensive, it has to be paranoid, because paranoia in this game is what keeps you solvent. All right? Let's get tactical. It's time to build our fortress. I call this the API cost control blueprint, and it has three layers of defense: the gatekeeper, the watchtower, and the kill switch. Let's repeat that so it sinks in. The gatekeeper, the watchtower, the kill switch. If you implement all three, you can sleep soundly at night. Let's start with layer 1, the gatekeeper. The gatekeeper is all about controlling access at the front door. It's about stopping runaway requests before they can even do any damage. The most common tool for this is rate limiting. This is non-negotiable. You absolutely must have rate limiting on any endpoint that triggers an expensive API call. Rate limiting means setting a maximum number of requests a user can make in a given time frame. For example, you could say a single user can only make 10 API calls per minute or 100 calls per hour. This immediately neuters the saboteur. Their script that tries to hit your endpoint thousands of times will get blocked after the 10th attempt. Most web frameworks and hosting platforms have middleware or plugins that make this incredibly easy to set up. You can rate limit by user ID if they're logged in, or by IP address for anonymous traffic. Don't just set it and forget it. Be smart. Your pricing page might need a higher rate limit than your free trial. Think about the user experience, but always err on the side of being more strict. You can always loosen the limits later. A strict limit won't bankrupt you, a loose one might. But rate limiting alone isn't enough. It stops high-frequency attacks, but it doesn't stop the superfan from making slow, steady, and very expensive requests all day long. That's why the second part of the gatekeeper layer is usage caps. This is critical. You need to set hard and soft caps on a user's consumption. A soft cap is a warning. For example, when a user on your $20 a month plan has cost $50 worth of API costs, you send them an automated email. You let them know they're a power user and that they might experience slower service or need to upgrade to a higher tier. This manages their expectations and gives you a chance to upsell. A hard cap is a kill switch for that specific user. When that same user causes, say, $100 in API costs, you shut them off. Their requests start returning an error message telling them they've hit their monthly limit. Does this feel harsh? Maybe, but it's infinitely better than letting them run up a $1,000 bill that you have to pay. Think of it like a prepaid phone plan. When the money runs out, the service stops. Your business model has to account for this. You should know the absolute maximum cost a single user on any given plan can incur, and your system should enforce it automatically. That's the gatekeeper: rate limits and usage caps. It's your first line of defense. Now for layer 2, the watchtower. The gatekeeper is great for stopping users, but it won't save you from the ghost in the machine, that nasty bug in your own code. Your code probably runs with special privileges and might bypass user level rate limits. That's where the watchtower comes in. You cannot wait for the monthly invoice to find out you have a problem. You need real time, instantaneous awareness of your spending. Your goal is to know about a cost spike within minutes, not weeks. The first step is to check what your API provider offers. OpenAI, for example, has APIs to check your daily cost usage. You should build a simple background job that runs every 5 or 10 minutes, calls that endpoint, and checks the total cost for the day. This is your canary in the coal mine. Now, what do you do with that information? You set up alerts. If the cost increases by more than, say, $50 in a single 10-minute window, you need to know immediately. This isn't an email that you might miss. This is a critical alert. It should send a message to a dedicated Slack channel. It should trigger a PagerDuty alert that calls your phone. It should be loud and impossible to ignore, because a sudden sharp spike in cost is almost always a sign of a major problem. It's a fire alarm for your bank account. You need to react instantly. The second part of the watchtower is setting budget alerts. Most cloud platforms like AWS, Google Cloud, and Azure allow you to set billing alerts. You should do the same with your AI provider. Set a budget for the month. Let's say it's $500. Then set alerts when you hit 25%, 50%, 75%, and 100% of that budget. This gives you a high-level view of your spending pace. If you hit 50% of your monthly budget in the first 3 days of the month, you know you have a problem. You have time to investigate and react before it gets out of control. The watchtower is about visibility. It's about turning an unknown, terrifying risk into a known, manageable metric. Never fly blind. Build your watchtower. We've built the gatekeeper to control our users. We've built the watchtower to monitor our costs. But what happens when the fire alarm goes off at 3 in the morning? What's the final line of defense? That's layer 3, the kill switch. This is the most powerful layer, and it's more about architecture than simple configuration. The core idea of the kill switch is to decouple the user's request from the expensive API call. When a user submits a request to your app, you shouldn't call the OpenAI API right away while they wait. That's a direct synchronous call, and it's dangerous. Let me explain this with a simple analogy. Think of it like a restaurant. Bad architecture is like the waiter taking your order and then just standing there at your table, staring at you while the chef cooks your meal. Awkward, right? And if the kitchen catches fire, the waiter is stuck there with you, watching everything burn. Queue-based architecture is different. The waiter takes your order, gives you a buzzer, and walks away. The kitchen makes your food in the background. You can relax. And here's the key. If the kitchen catches fire, the waiters just stop taking new orders. The restaurant doesn't burn down. The customers who already have buzzers might have to wait a bit longer, but nobody gets hurt. That's the kill switch. Instead of making the user wait while you call the API, the user's request gets placed into a queue. Think of it like that buzzer system. Your front-end application just adds a task to the list and immediately tells the user, "Got it, we're working on it." Then you have separate background workers, your kitchen staff, whose only job is to pull tasks from that queue one by one and then make the expensive API call. Why is this so much better? It gives you total control. If you get a cost spike alert from your watchtower, you can immediately pause the workers. No new API calls will be made. The requests will pile up safely in the queue, but they won't be costing you any money. This gives you time to breathe, investigate the problem, and fix it without the bleeding continuing. You can use systems like RabbitMQ or AWS SQS or Google Pub Sub for this. It adds a little complexity to your architecture, but the safety it provides is immense. It's the ultimate emergency brake. And we can take the kill switch concept even further. You can build a global, system-wide kill switch. This is a simple flag or value in a database or a configuration file. Your background workers, before they process any job from the queue, must first check the status of this global kill switch. If the switch is on, they do nothing, they just wait. You can then build a simple, secure internal dashboard or even a mobile app with a single big red button. When disaster strikes, you hit that button, and within seconds, every single expensive operation across your entire infrastructure grinds to a halt. This is your nuclear option. It's the final backstop that guarantees you can stop the financial bleeding no matter what the cause. The saboteur, the superfan, the ghost in the machine, none of them can get past a disabled system. This is what it means to build a resilient defensive architecture. It's about planning for the worst case scenario. It's about ensuring your AI hustle can survive its own success and its own mistakes. So let's review our fortress. Layer 1 is the gatekeeper. This uses rate limits and hard usage caps to control users. Layer 2 is the Watchtower. This uses real-time cost monitoring and alerting to detect spikes instantly. And Layer 3 is the kill switch. This uses queues and a global toggle to give you the power to hit the brakes immediately. If you build these 3 layers, you've turned an existential threat into a manageable operational risk. So, what's the first step you should take right now after listening to this? Don't try to build all 3 layers at once. That can be overwhelming. Pick one. The easiest one with the biggest impact is the gatekeeper. Go to your code base right now and add rate limiting to your most expensive endpoint. It might take you 30 minutes, but those 30 minutes could prevent a catastrophe. Then, next week, set up a simple alert in the Watchtower. Start small, build momentum, and layer your defenses over time. Because building a successful AI product isn't just about cool features and getting users, it's about building a sustainable, resilient business. And you can't be sustainable if a single user can wipe out your entire bank account over a weekend. Here's the truth. That $21,000 bill from the opening of this episode, it didn't happen to me, it happened to someone close to me, and watching them scramble to shut down their app, watching them give up on their dream because of a problem they could have prevented in 30 minutes. That's why I built this framework, the gatekeeper, the watchtower, the kill switch. 3 layers. One goal: make sure your AI empire survives long enough to become one. Jason's story doesn't have to be your story. You can build the defenses, you can be paranoid in the right way, you can sleep soundly at night knowing that no single user, no single bug, no single mistake can take you down. This isn't about fear, it's about freedom. The freedom to build, to scale, to take risks, knowing that your downside is protected. That is the real goal. Now go build your fortress. Thank you for tuning into AI Hustle Empire. If this episode gave you a concrete plan to protect your business, if it helped you defuse a ticking time bomb you didn't even know you had, then do me one small favor. Hit the follow button on Spotify. Or even better, share this episode with one other founder or developer who needs to hear it. Every follow and every share helps us reach more builders and create a stronger community of founders who are building the future. We release new episodes every week, packed with tactical playbooks just like this one. So follow along and let's build our empires the smart way. Until next time, keep building.